Welcome to the lecture, guys. In this lecture we are going to solve most important problem from Irodov itself, which may be asked in IIT JEE Advanced or IIT JEE Mains. My name is Anmol Kumar. I am MTech in Aerospace Engineering from Indian Institute of Science Bangalore and your instructor at iitpathshala.com. Guys, you can contact me anytime 24 into 7 on the prescribed number as follow. You can text me on WhatsApp or you can call me on my call number as I've mentioned over here. Now you can give free examination over my site. It's free for all. You can give the examination and reevaluate yourself. Now guys, before going into the lecture, please give it a thumbs up, like, share and subscribe my channel and hit the bell notification icon. Please check out my other cool videos on kinematics, HCVOMA solutions and over the tricks how you can solve your questions within 1 minute. Let us solve the following problem over here. So in the following problem, an artificial satellite of the moon revolve in a circular orbit whose radius exceed the radius of the moon by eta times. In the process of the motion of the satellite, it is experiencing a slight resistance due to the cosmic dust itself. You are assuming that the resistance force is depending upon the velocity as follow, and alpha is a constant. You have to find how long the satellite will stay in the orbit until it falls onto the moon surface itself. So guys, until now you were studying everything as the ideal case itself, that you are having an orbit, you are having a satellite S and it is revolving around this orbit with no drag whatsoever. But now in this question there is a drag. Okay, so there is a problem for you guys. Now how can we solve it? It is very easy to solve. Let us consider that instead of revolving in eta r orbit, in a orbit of having radius eta r, I am revolving in an orbit of an arbitrary radius r itself. Okay, now what I am doing is, because I have to calculate the time, only parameter which connects my time and energy is power itself. Okay, so I will be using this guy, power guy over here, to calculate my time. Okay, so now you know that force is given. To find power, it will be a piece of cake itself, because you know that power is nothing but force into velocity itself. Okay, now let us start the problem. Let us have the total energy of that orbit, which is nothing but this only. This is the mass of moon, this is mass of moon, mass of satellite upon radius r, this is the gravitational interaction energy, plus the infamous kinetic energy. Okay, this is my first equation. As you know that velocity in any orbit is nothing but this only. This is my second equation. Now power is nothing but dE by dt itself. Now guys, before derivating this whole equation, you can put this velocity over here and you can have the expression as minus g mass of moon mass of satellite upon 2r. This will be your expression of your energy itself, and now you can derivate it with respect to time. Why I am doing so? Because now I will be having everything in the parameters of radius r and time only. Okay, that will be easy for me. Okay, instead of having variable in the form of velocity itself. Okay, I have boiled down every variable to radius r and time t only. So the trick to solve every question is to boil down every multiple variable system into least variable system. Okay guys, so dE by dt whatsoever I'm getting by derivating is g mass of moon m upon 2r square dr by dt. That's the expression of dE by dt I am getting. Now from the logic itself, that power is nothing but it is force into velocity, I can write it as power equal to force into velocity. Force is given to me as alpha v square into velocity. It is nothing but will be equal to alpha v cube. Now guys, this force is nothing but it is a drag force. Okay, it is degrading your system, it is degrading your energy. So here minus will come, minus 1 will be there. Okay, it is degrading your energy. So equate both of the following equation. It is nothing but it is also dE by dt. Equate both of the following: mass of moon mass of satellite upon 2r square dr by dt equal to alpha v cube. Okay guys, you are left with the following expression over here, and again with a minus 1, which I am forgetting every time. Do not forget this minus 1 guys. Okay, now what you can do is just shuffle all the variables over here, okay, in the form of r and in the form of t itself. Now you have to consider that there is a velocity given to you. Velocity is there, so I can replace the following velocity by g m of moon upon r to the power 3. Okay, you have to replace this v by the following expression. Why? Because you are having both of your variable in the form of r and t only. Okay, now let us talk about the limit itself. Now for my time is going from 0 to t, and my radius is going from eta r, because you were in the orbit of eta r itself and you are landing on the moon. So henceforth you are having the resultant or the final radius as radius of the moon itself. Okay guys, so you can do the algebra, you can simplify the following expression. Okay guys, so this is the expression you will be leaving or you will be having after the simplification. More simplify it and you will be having the following expression as, and you are going from eta r to r itself. Okay guys, now you can solve the following problem very easily by the integration. Replace the values and you will be having the following expression as m alpha under root g m of moon itself. Let us take under root r outside to our expression itself, and you will be having eta minus 1. Okay, so this is the expression or this is the answer which we are getting. Now you can further simplify it, because they can further ask you that let us have the following expression in the form of small g and r itself. Okay, so as you know that under root gm is nothing but it will be equal to under root g multiply by r itself. So you can have the replacement over here and you will be having the following expression: m alpha under root g, under root r will be cut by this particular r over here, you will be having under root r under root eta minus 1. Okay, they can ask you any one of them. Okay, so you should be prepared. So guys, this was the most important question, and there will be more important question from Irodov itself in the videos itself, okay, in the upcoming video. So stay tuned on my lecture series on Irodov solution on most important problem which may come in the examination itself, because I will not mislead you in solving all the hundreds of problem from Irodo itself. Okay, I will give you only the important problem from the Irodo which may come in your IIT JEE mains. So we'll meet you in the next lecture. Until then, goodbye guys.